Good afternoon, I'm Purna. This is Data Science Ecosystem Lab, experiment number 4, Statistical Inferences. Here first, we want to import libraries, import pandas as PD, numpy as np, and matplotlib.pyplot as plt. Then we want to upload the CSV file. Then we want to read the CSV file. So our CSV file is diamonds.csv. Then df.head displays the first 5 lines from 0th index to 4th index of the dataset. Next, we want to find the sample mean for the price column, that is n is equal to 500. So here we are taking the random sample size as 500 and 1000 for the filtered prices. So then we are using sample 500 dot mean. So it will print sample mean n equal to 500 as 4018.046, and for n is equal to 1000 it will print 4002.93. Next we are going to find population mean. Population mean for the price column. So we will take all prices that were cut is good. Then we will use the entire filtered data set. So we will apply that price dot mean to find the population mean. So population mean, the output is population mean it will display. Then we will find the confidence interval for n equal to 500 in the price column. So here we import the scipy.stats for statistical functions. Then we use sample mean, standard deviation, and the sample size. Then for CI, we use t.interval confidence, level, degrees of freedom, mean, and SC. So standard deviation is equal to the standard deviation by the square. Then we will calculate the 95% and 99 intervals and store them. Next, we will find the plot intervals for 25. So here the loop is 25 times. So each time taking a sample of 500 prices, then we will compute the sample mean and the 95% of the confidence interval. So here store means the lower bound and upper bounds of the dataset. So we use plot dot error bar to plot each trial, see a confidence interval range. Then we draw a red dashed line for the population mean to compare. So this is the confidence intervals for the 25 trials, and in that price column, n equal to 500 and confidence interval is 95%. So the next is we will find the correlation coefficients. Here we use dot cor with method equal to Pearson for the Pearson correlation. Then we use dot cor method equal to Spearman for the Spearman correlation. So here Pearson checks the linear relationship of the blood pressure, and the Spearman checks the rank-based relationship of the weight and the blood pressure. So this is Pearson correlation coefficient. This is Spearman correlation coefficient for the column blood pressure. Then here covariance and correlation of the heat map. So here we use Seaborn and matplotlib. So for the column math, English and art, so we use the covariance matrix using .cov. So here we generate a correlation matrix with .corr. Here we are going to plot the heat map with the values given for the math, English and art. Then we give a color gradient. So this is the correlation for the maths, English, and art. Next, we are going to find the zero test hypothesis. Here, we store the sample mean, population mean, standard deviation, and the sample size. Then the formula of z-test is sample mean minus population mean divided by standard deviation by square. So we compare the calculated z value to the critical value 2.33. Then if that z-test is greater than 2.33, we will reject the null hypothesis and it will claim at 1% level. Then it will store the result as reject H naught or fail or claim not supported. So here we have the Z value and here we reject the hypothesis if that is not supported at 1% level. Thank you.